All right, so in summary, mTOR activation after resistance exercise happens in a growth factor independent manner. It doesn't need testosterone. It doesn't need growth hormone. It doesn't need IGF-1. It doesn't need any of those hormones. What it's doing, what you're doing when you're doing resistance exercise, is you're doing a stimulus that is overriding or going around these other growth factors. And actually, it's actually preventing the growth factors from actually signaling themselves. And we saw that from the data where I showed you that P85 associated with IRS1 goes down after resistance exercise. And that's because mTOR is activated in different ways by growth factors and mechanical stimuli. But they all come together at this one spot, TSC2. So you can either phosphorylate TSC2 in response to IGF-1 or in response to resistance exercise. If you have resistance exercise, you're not able to use the IGF-1 or the insulin or the testosterone-induced activation of mTOR. So unlike insulin, resistance exercise doesn't increase tyrosine phosphorylation of the insulin of the IGF-1 receptor. It doesn't increase IRS1 associated P85. I showed you that it doesn't increase AKT or PKB phosphorylation. So it's not doing any of those things that insulin does or IGF-1 does. Instead, something else, some sort of a mechanoreceptor, which is just sensing either tension or length, so load or tension or length, is sensing something across the muscle. And when that receptor is activated, it can in turn activate a kinase that can phosphorylate these specific sequences. And the Hornberger laboratory is trying to identify this kinase, and they've called this kinase the RIC, or the really important kinase. So the really important kinase, or the RXX kinase. So either way, I like really important kinase because it's the kinase that's then going to phosphorylate TSC2 in a growth factor independent manner and move it away from Reb. And you saw that in the Jacobs paper, that what's happening with resistance exercise is TSC2 is moving away from Reb. Okay, once free of TSC2, Reb can now, together with an unidentified GEF protein that can take out the GDP and allow Reb to bind GTP, now Reb is active, it's bound to GTP, and now it can activate mTOR and drive muscle hypertrophy. The important thing is that this really important kinase, this RIC, is activated by this mechanoreceptor, and it's activated for a much longer time than IGF-1 can activate mTOR or other things can activate mTOR. So instead of activating mTOR for 30 minutes to an hour, now we're activating mTOR for upwards of 12 hours to 18 hours. Okay, so this is telling us that there's a distinct mechanism through which load or tension is being sensed in cells that allows mTOR activation and growth that doesn't require growth factors.